Good morning to all the students. Welcome to the physics class. In the last video, we were discussing about the continuous charge distribution. In that, we discussed how the charge is distributed. Today, we will discuss the charge distribution for a volume, that is volume charge distribution. It is charge distribution spread over a three-dimensional volume. When there is a three-dimensional region, like we have a cuboid. These are some examples for the three-dimensional objects. When the charge is distributed in the volume, then we say that the volume charge distribution. Now here, students, as we discussed in the last video, that there is any lambda, that is line charge distribution, and formula for that was lambda is equal to charge per unit length. So likewise, we have here volume charge distribution and we have volume charge density. To calculate this, we have formula rho is equal to dq upon में dv means charge per unit volume. तो इस तरह से we can have the example of sphere कि कोई sphere है, sphere में sphere is the example of volume because it is three-dimensional object. तो sphere में जो charge distribution होगा that will be the volume charge distribution. अब to calculate the force, to calculate the electric field in the volume charge distribution, we have to suppose volume charge density as we discussed in the last video. So volume charge distribution, volume charge density is the charge per unit volume at that point. At any point we can consider this. The SI unit of rho, it is denoted by rho. This symbol is rho. So rho is volume charge density and its SI unit is coulomb per cubic meter. And now we know that here, to calculate the rho for a sphere, we know that the volume of the sphere is 4 by 3 upon में pi r cube. We know that rho is equal to charge upon volume. So charge is q, which is distributed r over the sphere, and volume of the sphere is 4 by 3 pi r cube. So in this way we calculate the rho for a sphere which have the q charge distributed over the entire volume. Now students, if we consider a very small volume of the sphere, that is dv, then what will be the charge at that in that volume, distributed in that volume? We can calculate with the help of this rho. We know that rho is equal to dq upon में dv. So from here, if we want to calculate the value of charge, then charge will be equal to rho dot dv. The product of volume charge density and the volume will give us charge at that point, at that volume. Now students, now we can apply the formula of the force as suggested by the Coulomb. We know that the formula, that force is equal to 1 upon में 4 pi epsilon naught q upon में r square. Okay, now this formula we have derived earlier, it is here. So this formula we have used for the continuous charge distribution. We know that for the quantization of the charge, for the point charges, we have the formula 1 upon में 4 pi epsilon naught q upon में r square q1 q2. Now here instead of q2 we will write dq. and instead of Q1 we will write Q0, because here we considered that the charge is distributed continuously, not it is, we ignore the quantization nature of the charge. So similarly, this formula we have derived in the last video, or it is derived. This formula we will use for the volume charge distribution. Now students, here we have this formula and we have calculated the value of dq. What is the value of dq? We have calculated that dq is equal to rho into dv. So that value of dq we will put in this formula and calculate the force. Now, so as you can see here, we just put the value of dq, that is rho dv, and calculated the force for the entire volume V. Now students, now for the electric field, we know the formula that electric field is basically the ratio of force per unit test charge. Now students, we can calculate the electric field. We know that the value of force we have calculated, and just divide this with the Q0 and we will get the electric field. So this is the expression for the electric field for the entire volume when the volume is distributed, when the charge is distributed over a volume. Now student, our next topic is surface charge distribution. Now what is surface charge distribution? We have studied the line charge distribution, the volume charge distribution. So students, when the charge is distributed in the one dimensional, then we say that this is the line charge distribution, and when it is distributed in 3 dimensions, then we say this is the volume charge distribution. Now what is surface charge distribution? When the charge distributed over 2-dimensional space, then we say that this is the surface charge distribution. Suppose a sheet, a charge is distributed all over the sheet. As we know that we can neglect the thickness of the sheet when it is very thin sheet, so we can neglect the third dimension. We can only only consider the length and the breadth. So there are only 2 dimensions. So this charge is distributed all over the sheet, and we can say that this is spread over the 2 dimensions. Now students, when this happens, then we say that charge is distributed over a surface, and for that we have to consider, as we considered in the volume charge distribution and we considered in the line charge distribution, here we also consider the surface charge density. So as we have the volume charge density, we have the line charge density, we also have the surface charge density. Now what is surface charge density? It is the ratio of charge which is spread over the surface per unit area. Now here is the formula. Sigma is equal to, sigma is the surface charge density. Sigma is equal to dq upon me ds. Now what are the units? Units is coulomb per meter square. This is the unit of sigma, that is surface charge density. Now students, suppose there is a big sheet and charge is distributed over this sheet. Let Q be the charge distributed uniformly, and we can find out the sigma. We know that sigma is equal to charge upon surface. Now what is the surface of this surface area of this sheet, it is 4 pi r square, but we will not consider the full area. We will only consider the small area ds, and we will calculate the force for this. Now students, we know that sigma is equal to dq upon में ds. So we can calculate the value of dq as we did in the volume charge distribution. Now dq will be equal to sigma ds. Now from here we can put the value of dq in the expression of the force and we calculate the force. So here is the expression for the force, where we have put the value of dq. Instead of writing dq, we will write the sigma ds, where sigma is the surface charge density. Similarly, we can find out the value of the electric field as we discussed in the volume charge distribution. So this is our 3 types of charge distribution. Thanks for attending the class.